The mission he's talking about was the iSpace Hakuto and the Firefly Blue Ghost mission that we launched. As you all see on the webcast, the first stage returns to Earth, but the second stage we need to appropriately dispose of. So for low Earth orbit missions, we nominally would perform a burn or a maneuver to demise the second stage to appropriately deorbit that stage. But for high energy missions, we need to perform a different maneuver to ensure the second stage itself is safe per the appropriate rules and regulations. And so we did that here for the iSpace and Blue Ghost mission, that second stage. And what has happened is essentially a mixture of solar activity and gravity forces have put it on a path towards the moon. As a scientist, I also am very excited to see the observation. But yes, it's one of the things that we're working in partnership with NASA and the other appropriate agencies is what is the best future disposal path for high energy missions that are in the Sun, Earth, Moon system. And so, yeah, we're pretty excited about it. I know a lot of the teams are going to go observe the disposal, so pretty exciting.
So the impact is going to occur at a crater called, or around a crater called Einstein crater, which is right here on the moon. If you look up at the moon in the night sky, you'll see this big dark patch. That's Oceanus Procellarum. It's the biggest dark patch that you'll see on the moon. It's on the near side. The back side, or the far side of the moon, sometimes called the dark side of the moon, is over on this side. But right at we call it the limb, is where this impact is going to occur. We don't normally get a very good view of Einstein crater from the Earth because it's right at the edge. And that's what makes this impact really unique, because that plume that's maybe between 50 kilometers and 75 kilometers high is going to go off into space in this direction, and it'll be, the blackness of space will be behind it. And so it'll be illuminated by the sunlight, reflected to Earth. We'll get a really great view of the height and distribution of this plume right at the edge of the lunar surface. It should be pretty bright. So this is kicking up a lot of dust, and it'll be illuminated by the sunlight that gets scattered back to the Earth. So it should be a relatively bright feature. Whether you see it with the naked eye or with binoculars or a home telescope depends on a lot of things, the atmosphere and things like that. So the impact will happen around this crater here called Einstein crater. It's actually two craters. There's Einstein, which is this larger crater, and then you can see within it there's a smaller crater called Einstein A. My name is Craig Hardgrove. I'm a professor in the School of Earth and Space Exploration at Arizona State University. I'm a planetary geologist. I study water on Mars and the moon. So in 2025, a rocket launched that was carrying 2 lunar landers to the surface of the moon. And the upper stage of that rocket, which is a Falcon 9, wound up in orbit between the Earth and the moon. And that upper stage is about to crash into the surface of the moon. So this is an opportunity for us to observe a crash on the surface of the moon, unlike most of the ones that we get to see, which are completely random, from random space rocks that happen to hit the moon, and we have to be randomly looking at them at the right time. This is an opportunity where we know exactly what the material is. It's an upper stage of a rocket. We know how much it weighs, we know how fast it's going, and we know what the material is that it's going to be hitting into. So it's a great opportunity to do a somewhat controlled physics experiment where we can observe the impact and predict what we expect to see based on models of the lunar surface and understand how deep the crater will be. We're going to actually get to see a large plume from the Earth that is due to the unique geometry of the fact that this upper stage is hitting into the limb of the moon as opposed to just face on. We'll see a large plume emitted from the surface where the rocket hits in this crater called Einstein crater. There's a whole set of telescopes around the world that will be pointed at the moon during this impact, taking images. Those will be made available online. Scientists and engineers will be studying these in part to learn about the lunar dust dynamics and how the regolith and rocks move in the lunar environment, as well as for planning future landers to understand what the surface is like when it's hit with something pretty hard. We'll also have orbiters that are orbiting the moon that will take images of the impact site afterwards, and those will be very, very high resolution impact images, and we'll be able to map the site and understand all of the dynamics that occurred during the impact. We don't know exactly where it's going to land, but it will be in an area around what's called Einstein crater. And Einstein crater actually has a crater within it called Einstein A. And somewhere in that area is where this rocket will land. And so if you imagine a cratered plain where we have a bowl-shaped crater and then debris scattered throughout the landscape, rocks and dirt, usually this is called the debris apron or the envelope that the original impact crater deposited a bunch of lunar rocks and soils around. And so that's what the rocket's going to hit into. The upper stage of the rocket will land into that. And so all of that material is going to be lofted up into the air, and it's going to create a little mini atmosphere, and that is likely to be on the order of 50 to 75 kilometers high. And that's the plume that we're going to see from the Earth and with our telescopes. And then we'll see that actually settle out. And the height of that will tell us something about how the lunar regolith formed and how it evolves over time and what's actually going on underneath, because this is going to excavate a crater about 5 meters deep and probably about 20 to 30 meters in diameter. Yeah, so when the upper stage hits, again, we have no control over this impact. So there's a lot of models that are going into which part of the upper stage will hit first, and that determines the overall shape. But the initial models that people have put together show that the impact will excavate a crater about 5 meters deep and around tens of meters in diameter. And it'll loft a plume of rock and dirt and dust up into the lunar atmosphere, somewhere between 50 and 75 kilometers high. We don't know exactly, and so one of the important measurements will be how high is that lofted. We rarely get the opportunity to know exactly what the material is that's impacting the moon. It's going to be hitting the moon around 5,000 miles per hour. We know the speed. We know exactly what it's made of. We know how much it weighs. And so that's going to really tell us how the lunar regolith responds and what happens underneath the surface. And that helps us plan future missions. It helps us understand what's going on with the dynamics of the moon at depth and how it responds. So that's yeah, it's going to be a kind of a wasteland in that area of the moon for a little while. So, as scientists, we're always excited for some new opportunity to do an experiment, and this is a nice opportunity where we get to know everything about the dynamics of what's happening as far as we can, and then test a model or hypothesis about how the lunar surface is going to behave. So I think from a purely scientific perspective, we're excited to see what happens, what the plume does in the minutes after the impact and how everything settles out. So yeah, it's sort of taking this opportunity to have this maybe rogue upper stage crash into the moon and make some interesting science out of it.
大家好，我是主播周玉琴。很多的朋友告诉我们，选择原版的太阳星全效克菲尔益生菌，它添加有羽衣甘蓝，健康再加分。而有睡眠困扰的朋友们，赶快选择蓝色包装这一款晚安加强版，绝对是更有感。每日克菲尔，时刻美好 ，Good Feel。Feel good， 请上快点购为健康下单，而且要记得输入推荐代码，有额外的折扣优惠。太阳星全效克菲尔益生菌基础版、晚安加强版，新包装改版，内容不变，抽取更方便。要吃就吃最好的。